So now we're on to the sequel to the videos where I've referenced this. It's like waiting for in-game, but you didn't have to wait a whole year to get in-game part 2. So removable discontinuity. Well, you did have to wait a year for that. You don't have to wait a year for this because this is all available to you right now, free of charge. Removable discontinuities. Removable discontinuity is a hole in the graph, a single point where the graph is not defined, indicated by an open circle. Now the circle, by the way, that point, it's a single point. It'd be infinitely small, so you wouldn't really see it. We exaggerate it with a circle, and I know the circle extends beyond where you would probably normally have seen the, you wouldn't really be able to, if you graphed it on your calculator or in Decimus, you wouldn't be able to see it. So think about this graph right here. F of x equals x plus 1 times x minus 1 over x plus 1 times x minus 3. And notice that there is a vertical asymptote at 3, but there's no asymptote at -1. Instead, we have the hole there because this would reduce out. But it's still not defined there. As we talked about in the domain of functions, it's still not defined there. So we have to leave a hole so that the graph basically would be jumping over that. It's not a continuous point or a continuous graph. So a removable discontinuity of the rational function. A removable discontinuity occurs in the graph of a rational function at x equals a if a is a 0 for a factor in the denominator that is common with a factor in the numerator. We factor the numerator and denominator and check for common factors. If we find any, we set the common factor equal to 0 and solve. This is the location of the removable discontinuity. This is true if the multiplicity of this factor is greater than or equal to that in the denominator. If the multiplicity in the factor is greater than in the denominator, then there's still an asymptote. So, like in this last one here, if this was x plus 1 squared down below, you'd still have an asymptote because only one of them went away. Okay. So let's look at this one. Find the vertical asymptotes and removable discontinuities of this graph. And it didn't say we had to graph it, but I thought I'd throw this on here anyway. So we're gonna have x minus 2 on top, and then an x plus 2 times x minus 2 down below. Now the x minus 2's would divide out, leaving us with k of x equals 1 over x plus 2. So there's a vertical asymptote at x plus 2 equals 0 or x equals -2. So we're going to have that vertical asymptote there. But the x minus 2 wasn't for nothing. So x minus 2 equals 0 means x equals 2. That's where there's a removable discontinuity. And our graph is going to look something like this, coming down. Oops, I'm not drawing that right. We have an open circle here, like that. Okay, and that is the graph that's of the discontinuity. Let me clean this up a little bit. I wish my eraser worked like it was supposed to. Okay, there we go. That's it for this video.